Revision of basic geometrical ideas. Points. These dots are called as points. It determines a location. It is represented by capital letters like A, B, C, D and E. Line segment is the shortest route between the 2 points. This is called as the line segments, where A and B are the end points of the line segment. You can name this line segment as AB or BA. Line. When you extend the line segment in both the direction, then it is considered as line. You can take any 2 points on the line and you can represent the line writing any 2 points with the symbol like this. So this is how we represent a line. Or you can represent a line with a small letter like L, M and so on. Intersecting lines. When two straight lines, say L and M, they intersect at a point, then they are called as intersecting lines. Parallel lines. Parallel lines are the lines which do not intersect at any point of time. The perpendicular distance between these two lines is always fixed. Ray. A ray has got a starting point or the initial point and goes in infinity in one direction. It is a part of a line. Let us name this initial point or the starting point as O, and you can take any point on this ray as A. So you can name this ray first with the initial point you should write, and then you can write down any point on the ray. Here I am taking A. So this is how we denote a ray. How many lines can pass through one given point and two given points? So let us first take the first part, one given point. So this is the one given point. How many lines you can pass through one given point? You can make infinite line passing through one given point. So the answer is infinite. Now two given points. So there are two given points. How many lines you can make through two given points? Only one line. So answer is one line can pass through two given points. And through one given point, infinite lines will pass. Next question. Consider the following figure of line MN. Say whether the following statements are true or false in context of the given figure. So this is the figure given to you. Using this figure, you have to answer these questions. Ray OP is different from ray QP. Ray OP is here and ray QP is here. So you can clearly see the source point is different. For OP, the source is O. For QP ray, the source is Q. So they are different rays? Yes, they are the different rays. So answer is true. O is not an initial point of OP. Is false. That is how we write it. You can see this is ray OP. First we write down the initial point of the ray and then you can take any point on the ray to name the ray. So OP ray is here. So the source is O or the initial point is O. So the answer here, O is not the initial point, is false. It is the initial point of the ray OP. N is the initial point of NP and NM. So you can see that NP is here, ray NP, and ray NM is here. They both have the same initial point N. So N is the initial point of NP and NM. Answer is true. QM and OP, QM and OP are the points on line MN. You can take any point on this line and name the line. They have taken M and N as the point and named this line. And on this line, you can see all these points are line. So the answer here is true. M and N are the endpoints of the line segment. Yes, because that is how you name it. You take the endpoints M and N, which they have written it here, and then you name it. So MN is the line segment here. They are the endpoints of this line segment. So the answer is true. Curves. Curves, anything which you can draw without lifting your pencil is called as curve. All these are curves. Generally, we talk about curve as something which is not straight. But in mathematics, you can draw this straight line without lifting a pencil. So, even this is a curve. Simple curve. Simple curve is a curve which does not cross each other. Like this is a simple curve. At any point of time, it is not crossing. But this is not a simple curve. Why? Because it is crossing here at this point and it is crossing at this point. So this is not a simple curve, where this is a simple curve. Open curve. Open curve is a curve where the starting and the end points do not overlap. You can see it is open from this side. So this is called an open curve. Closed curve. Closed curve, the starting point and the ending point, they overlap. So this is a closed curve. A closed curve has got three parts: interior, boundary and exterior. The region inside, this is called as the interior of the closed curve. Interior, as it says, inside the curve is called as interior. Boundary is on the curve. This is the boundary. Boundary is on the curve. Exterior is outside the curve. So this is called as exterior. And region is the interior along with the boundary is called as region. So this is called as the region. Along with the boundary, it is called as region. Polygon. Polygon is a simple closed curve made up of entirely of line segment. It is simple. That means it is not going to cross. First of all, it is a curve. You can see that you can draw this polygon without lifting a pencil. It is simple because it is not crossing at any point of time, and it is closed. It is made up of entirely of line segments. So, a polygon is a simple closed curve made up of entirely of line segments. What is side? The line segments that forms the polygon is called as sides. Let us name this polygon as A, B, C, D and E. So A, B, C, D, E is a polygon. Sides, the line segments forming the polygon is called as the side. So AB is the side, BC, CD, DE and EA are the sides of this polygon. The meeting point of the sides is called as the vertex. AE and AB meet at the vertex A. AB and BC meets at the vertex B. So B, C, D and E are the vertices of this polygon. Adjacent sides are the line segments that have common endpoint. So AB and BC have a common endpoint B. So AB and BC are the adjacent sides. If we take BC and CD, they have a common endpoint C. So BC and CD are the adjacent sides. If you take point D, here CD and DE are the adjacent sides. If you take point E, then DE and EA are the adjacent sides. Similarly, if you take point A, EA and AB are the adjacent sides. So EA and AB are the adjacent side. Adjacent vertices are the two end points of the line segment. So if you take AB line segment, what are the adjacent vertices? A and B. So A and B are the adjacent vertices. If you take line segment BC, B and C are the adjacent vertices. If you take CD, then C and D are the adjacent vertices. You take DE, D and E are the adjacent vertices. E and A are the adjacent vertices. Diagonals, it is a line segment that connects the vertices which are not adjacent. For A, B and E are adjacent, C and D are not adjacent points. So AC is the diagonal and AD is the diagonal. So AC and AD, they are the diagonals. So if you take B, A and C are the adjacent vertices. D is not adjacent vertices. So you can join with this, and E also is not a adjacent vertex to point B. So here BD and BE are also the diagonals. You take C, B and D are adjacent vertices, A and E are not adjacent vertices. It is already connected to A, you just need to connect it to E. So CE is the diagonal. If you take D, it is already connected to the points which are not adjacent to this vertex D. Similarly for E, D and A are the adjacent vertices. It's already connected to the C and B. Angles. Angles are formed when the two rays, they have the same initial point. This is the ray OA and this is the ray OB. They have the same initial point O. OA and OB are called as the arms of the angle, and this point O is called as the vertex. The common source or the common initial point is called as the vertex. How do we denote this angle? You can denote it by angle BOA. You need to make this angle symbol. The vertex angle is kept in the center. So if the same angle can be named like this also, angle AOB, because here also vertex O is in the center. This is the angle AOB or BOA. Angle has also got three parts: interior, on the angle, and the exterior. If I name this as X, Y and Z. So the region between the two arms of the angle is called as the interior. This area is not restricted. It goes to infinity. So point X is in the interior of this angle BOA. Point Y is on the angle and point Z is in the exterior of this angle AOB. Triangles. Triangle is the smallest polygon. It has got three sides. Let us name this triangle. This point is say A, B and C. So, points A, B and C are called as the vertices. So A, B and C are called as the vertices since they are the points we represent with the capital letter. Sides, they are the line segments. So the sides are AB, BC and CA. AB, BC and CA are the three sides. Similarly, you have the three angles. This angle, angle BAC, and this angle is angle ABC, and this angle, we make this angle symbol and we write it as BCA. And instead of writing triangle ABC, we represent it like this. We make a triangle symbol and we write the three vertices ABC. So this is read as triangle ABC. Quadrilateral. A quadrilateral is a polygon which has got four sides. Let us name this quadrilateral. You have to name it in cyclic order. So this is A, B, C, D. The naming of the quadrilateral is very important. So either you can name like this or you can name like this, but it should be in cyclic order. So what are the sides of this quadrilateral? AB, BC, CD and DA. So the sides are AB, BC, CD and DA. What are the angles? You can write it as angle A, angle B, angle C and angle D, because at each vertex there is only one angle formed. So if you want, you can take this in the center and write it as angle BAC or AB is DAB. So you can write it as angle A. This is equals to or same angle, it is angle BAD. So you can name it like this. So there are four angles: angle A, angle B, angle C and angle D. You need to make the angle symbol. That is very important. If you don't make this angle symbol, then it looks like a point or vertices. Adjacent sides. Adjacent sides will have one endpoint in common. So what are the adjacent sides here? AB and AD are the adjacent sides. AB and AD are the adjacent sides. If you take now point B, AB and BC are the adjacent sides. AB and BC are the adjacent sides. Similarly, if you take point C, BC and CD are the adjacent sides. If you take point D, CD and DA are the adjacent sides. Opposite sides, AB and CD, they are opposite to each other. So, AB and CD, they are the opposite sides. And BC and AD, they are the opposite sides. So, AD and BC, they are opposite to each other. So, they are as the opposite side. They don't have any point in common. Adjacent angles, they are at the end points of the side. So angle A and angle D are the adjacent angles. Angle A and angle D are the adjacent angles. Similarly, if you take CD as the side, then angle D and angle C are the adjacent angles. Similarly, if you take BC, angle B and angle C are the adjacent angles. If you take AB, then angle A and angle B are the adjacent angles. Opposite angles. Angle A and angle C are opposite angles. Angle A and angle C are opposite angles. Angle B and angle D are opposite angles. Angle B and angle D are opposite angles. Circle. Circle is a simple closed curve. It is not a polygon. It has got some interesting properties. Every point on the circle is equidistant from the center of the circle. This is the center of the circle. It's a point, so it can be marked with a letter. I have marked it with O. So the center of this circle is O. Radius is a line segment that connects the center of the circle to any point on the circle. Let us name this point as A. So OA is the radius of the circle. Diameter is double the radius of the circle. So similarly, we will draw it in a straight line from center of the circle to any point on the circumference. So this is also the radius and this is also the radius. I represent diameter with capital letter D. So diameter is twice the radius. And here AB is the diameter of the circle. The A and B, both the points lie on the circle. Chord. Chord is a line segment that connects any 2 points on the circle. Here C and D are on the circle. So CD is the chord. Arc. A portion of the circle is called an arc. This is called an arc. You can write the arc as arc CD. This is the arc CD. When we talk about chord, you can see in the diameter A and B, they lie on the circle and AB is the line segment that connects the 2 points. So AB, the diameter is called as the longest chord of the circle. Sector. Sector is the region enclosed by the two radius and the arc of the circle. So this is called as sector. Segment is the region enclosed by the chord and the arc of the circle. This is called as segment. Circumferences. The boundary of the circle is called as the circumference. The diameter of the circle divides the circle into two equal parts. That is called as semicircle.